Okay, so this is part 2 of the video lecture series for integrals of transcendental functions. Okay, so from the last video lecture, we are cut off with the presentation of the examples on the transcendental functions. Okay, so also from the previous video lecture, I have presented to you some examples for the recall of the formulas in derivatives in finding the derivatives. Now, in this video lecture, we will be reversing the process of getting the derivative or the antiderivative, starting with the forms of the function in the form of logarithmic and exponential functions. Okay, so let's start with this example. This is the integral of the square root of 10 raised to 3x derivative of x. Okay, so for this problem, first thing to do is to convert the given radical form into exponential form or exponent form. So what we have here is that, of course, converting the square root to fractional exponent, that is actually 1/2. So that this becomes, therefore 10 raised to 3x becomes square root of 10 raised to 3x becomes 10 raised to 3x over 2. Now, if we're going to represent 3x over 2 as u, this becomes u is equal to 3x over 2. Next step is to get the derivative of u. The derivative of 3 halves x is, of course, 3 halves dx. As you can see here, this is 3 halves dx. Okay, so although it is not seen here, but the representation of u should be that this becomes 10 raised to u du with an introduction of 2/3 in order to maintain equality. So although this is not seen here, but I'm inviting you to get your own pen and paper so that you could follow the steps of transition that has been done here. Okay, so let's start with the given integral of square root of 10 raised to 3x derivative of x. Now, the integral was converted into integral of 10 raised to 3x over 2 derivative of x. Next is to let u equal to 3 halves x. Okay, so next is to get the derivative of u, which is du is equal to derivatives of 3 halves. The derivative of 3 halves x is, of course, 3 halves dx. Now, once you have solved for the derivative, you solve for dx. dx should be equal to 2/3 du. Okay, so I hope you follow that using your own pen and paper. Now, in the next step, let us replace the original integral 10 raised to 3x over 2 dx by integral of 10 raised to u 2/3 du. Okay, so inside your integrand, you have the constant 2/3. So since this is a constant, just like what was presented in the earlier video lectures, a constant within your integrand could be placed outside the integral sign. So to minimize the confusion in doing the process of integration. So therefore, we could write the integral as 2/3 integral of 10 raised to u derivative of u. Now, you should be left with 2/3 integral of 10 raised to u derivative of u. Now, try to recall this is of the form 10 raised to u du is of the form of an integral of a raised to x. Now, it follows that you're going to apply here the formulation of reversing the process for the getting the logarithmic or the exponential function. Okay, so next is doing the integral of 10 raised to u derivative of u. Now, the formulation would be the integral of 10 raised to u is 10 raised to u over ln of 10. Okay, so 2/3, the integral of 10 raised to u du is 10 raised to u over ln of 10, then plus c. So that process appears here as 2/3 10 raised to u over ln of 10. Now what happens here is that uh, the representation of u was replaced by its original given as 3x over 2. So our 2/3 10 raised to u becomes 2/3 10 raised to 3 x over 2 over ln of 10, then plus c. So therefore, trying to go back to the radical form of this of 10 raised to 3x over 2, then simply this becomes 2 raised to square root of 10 raised to 3x over 3 ln of 10. Okay, so the transition formula here is actually the integral of the form of 10 raised to 10 raised to u, derivative of u. So if you're going to write that down, okay, so you need not to worry. I'll be giving you a copy of this document. So important integrals. Okay, so the first form is okay, so insert. Okay, so what we see here is that I'm writing the form of the integral that we have used the form of the integral of the form integral of a raised to x dx. So the result here is supposed to be integral of 10 raised to u over ln of 10 is of the form of 10 integral of a raised to u is equal raised to u du is 10 raised to as a raised to u over ln of 10, then plus c. So this becomes a raised to x over ln of a, then plus c. Okay, so this is the first form. Integral of a raised to x dx is a raised to x over ln of a, then plus c. This is the formulation that what was employed here. Integral of 10 raised to u du is 10 raised to u over ln of 10. Okay, so next step, I'll be having this formulation. Next is the integral of e raised to u du is equal to e raised to u plus c. Okay, so let me write that down. Okay, so this is integral of e raised to u a raised to x dx is equal to e raised to x, then plus c. There. So integral of e raised to x dx is equal to e raised to x, then plus c. Now let's have an example for e raised to u du. Okay, so take this example, integral of e raised to square root of x over square root of x dx. So what was done here is we let u equal to square root of x. So du, you need to perform this the formulation for u equal to x raised to 1 half. So follow on the solution by writing the description on your own. So again, if you have your own pen and paper with you, you could write down u is equal to square root of x is equal to x raised to 1 half. The conversion of the square root to fractional exponent. So this becomes is equal to x raised to 1 half. Now, doing the derivative for u, derivative of u is derivative of x raised to 1 half, so that is 1 half x raised to negative 1 half dx. Okay, so you have du is equal to 1 half x raised to negative 1 half dx. You have x having a negative exponent, negative 1 half, so you could bring down that to the denominator to get the reciprocal. So what happens here is you have dx over 2 square root of x. So that is what is that appears here, 1 over 2 square root of x dx. This is actually the derivative of u. Now, so if you're going to replace our representation for x in terms of u, our original integral of e raised to square root of x over square root of x becomes, okay, so first is this becomes e raised to u over u, then dx becomes, try to notice that dx here could be represented as 2 du, right? Try to replace the representation as 2 du is equal to dx over square root of x. So therefore, if you're going to write this down in the form of e raised to u times dx over square root of x, which is 2 du, so 2 du, so you could take the 2 outside of the integral, so this becomes 2 integral of e raised to u du. So it follows that what is left in the process to get the integral of e raised to u. And of course, e raised to u is the integral of e raised to u du is equal to e raised to u times 2 outside. This becomes 2 e raised to u then plus c. And the final answer should be expressed by the substitution of our original representation for u as square root of x. Okay, so there are exercises here, exercise 1, 2, and 3. I'll be asking you to do these exercises, and this will be submitted on Monday, May 2. Okay? I'm asking you to do this using your handwriting. You try to scan your handwritten solution, then you send the handwritten solution in JPEG format through my email. Okay, so next, the third one, the integral of du over u, which is equal to ln of u plus c. The integral of one over x derivative of x is equal to ln of x then plus c. Okay, so integral of 1 over x derivative of x is equal to ln of x then plus c. Okay, so let's have a few examples. Okay, so we have integral of 1 over u du ln of u plus c. So let's have an example for this one. Let's have evaluate the integral of x squared over x cubed plus 1. Okay, so for this example, I suggest again that you have your own pen and paper and you follow on with the description of how to arrive with each step of the solution. Okay, so first step here is to let u equal to the form of the denominator x cubed plus 1. Now again, why is it that we represent u in terms of x cubed plus 1 as our choice, not x squared? The basic idea is that you represent u with the expression in your given integrand with a more complex exponent. So between x squared and x cubed, of course x cubed is the more complex, so we represent the entire expression containing the more complex exponent with our u. So from there we represent u equal to x cubed plus 1. Then the next step is you compute for du. Du, or the derivative of x cubed plus 1, this becomes 3x squared dx. 3x squared dx. Now try to notice that in our expression, in our original given, we already have the expression x squared dx. Okay? And also that expression x squared dx appears in our derivative of u, which is 3x squared dx. So you have you have x squared dx there. So if you're going to solve for x squared dx in terms of du, that becomes du over 3 is equal to x squared dx. Now, if you have followed that, we can now replace the form of the integrand here as du over 3 all over u. So try to follow on with the description described here in the video. Okay, so you start here, integral of x squared over x cubed plus 1 dx. You let u equal to x cubed plus 1. Find the derivative of u by finding the derivative of x cubed plus 1. The derivative of x cubed plus 1 is 3x squared derivative of x. Now, so from that derivative, the expression x squared dx appears in that derivative, and you represent x squared dx in terms of du by solving for x squared dx. X squared dx is du over 3. Okay, so make the necessary substitutions. So this expression becomes du over 3 all over u. Now you would have a constant 1/3 inside your integrand, and again the constant could be placed outside the integral sign so that you could simplify the integrand further. So this becomes 1/3 integral of du over u. Okay, so I hope you have followed that. We are now on the step 1/3 is 1/3 integral of du over u. Now the next obvious step is to perform the integral of du over u, which is ln of u. Now the result would become 1/3 ln of u, then plus c. Of course, this becomes 1/3 of ln of x cubed plus 1, then plus c. So that is why our answer here is 1/3 ln of x cubed plus 1, then plus c. Okay, so let's try another example. So we have integral of x squared plus 2 over x plus 1 dx. Again, as a suggestion, we will start the representation of your integrand with the by representing the more complex of the two expressions. So between x squared plus 2 and x plus 1, x squared plus 2 has the higher exponent, therefore x squared plus 2 would be the more appropriate representation for u. So we let u equal to x squared plus 2, So if we're going to get du, du becomes 2x dx.